Okay, so this topic, what the press doesn't tell you about climate change, comes out of a little bit of frustration in reading accounts of climate change in the press, and the fact that the way that climate change is covered in the press seems to be not quite enough to express what kind of problem it really is. And what I'm going to talk a little bit about the way the press covers it in terms of statistics and votes. Then I'm going to talk a little bit about dynamics and about tipping points and basin boundaries, and then talk about how poles and ice change the actual weather and not just the sea level and so forth. And then I'm going to finish up talking about a topic that has recently become quite popular, which is about people's diets and how much that has to do with climate change. All right, so I need to scroll this, so be patient with me. So statistics and votes. Wow. Those S's are not supposed to be there. We hear the following. We always hear the following on if you're like watching, say, cable news or something like that. That 97% of scientists believe in climate change. Frequently quoted statistic. February was the third hottest month on record, which is true. This past February was that. So February was the wettest month on record. Past February was the wettest month for the contiguous United States. As the climate warms, the likelihood of extreme events increases. So there's nothing wrong with these things. It's not that the press has got anything wrong here. It's just that we hear this because what we hear is statistics like this, or we hear, in the first case, what is essentially a poll. And we hear that because that's kind of what the press is comfortable with. Statistics within sports coverage, polls within election coverage, for instance. We also hear it because it's the most defensible thing for scientists to say if they're worried about being, swarmed by climate deniers. And we hear it because it's the easiest thing to explain. And my point of this talk is not that that's wrong, but it leaves people believing that what will happen is pretty much summed up by a sea level change and some record-breaking storms. And that's kind of not the case. So I'm going to start off with a little backgrounder, a little bit of classroom stuff. State space. A state space, you can think of a state space as being the entire state of something. So if I'm talking about the climate, I might measure things. If I was talking about the weather, for instance, I might measure the temperature, the humidity, the barometric pressure, and that would be 3 dimensions. I could add some more dimensions to that. I get a space that basically where something is in the space tells you exactly what the system is doing. That's known as a state space in physics. It's a very frequent thing to use, and it's needed to explain one concept. In state space, when I'm at an equilibrium, if the climate is going to stay pretty much the way it is, which it's not, but if the climate stays pretty much the way it is, then it's at an equilibrium. And in terms of state space, that means it's in some kind of basin. And it's like this rolling ball here. If it moves a little bit away from that equilibrium, it'll rock back until it hits the equilibrium again. But what can happen is that the ball gets pushed far enough that it gets up here. If it crosses this point here, it's going to roll away from where it had been, and the climate will change. A lot of times these basin boundaries are known as tipping points because when you pass them, things change, and they may not change back. It would roll, it may end up over in here. And you can think of these in more dimensions as being sort of like craters with funny shaped rims, funny shaped boundaries. And the point of putting 2 crater slides up on is it's not the only crater around. If it moves out of there, it moves to some other place. All right? So, with that in mind, it should be said that attractors and basins come in lots of different shapes. If it was in something like this, it could go around in a circle like that and stay within the basin, but if it climbed up, it would climb up and out. In this case, if it climbs up, it could probably sit around on the rim for a while, but that would eventually be unstable. It had to go someplace, back in or out. It could be more shaped like this, in which case if it was rolling in this direction, it'd be okay, it'd come back to the center, but if it was rolling in this direction, it'd fall off. Make sense? They don't have to be this simple. This is also a basin. This is called the Lorenz Attractor, and Ed Lorenz did this in the early 1960s as an explanation of weather phenomena, modeling of weather phenomena. And this was, and the fact that any way you roll around this thing, you stay inside of that thing, makes it the attractor, like these other things. But the fact that it's so complicated means that, among other things, Ed Lorenz was able to show that you can't predict the weather a month away. Does that make sense? Okay. So one of the things about that is if you move out of the basin and you move into a new basin, the new basin becomes what we nowadays use the phrase, the new normal. The old normal is gone. Okay. So there's three reasons for talking about this. The first is the Gaia Hypothesis, which I'll attack on the next slide, which looks at the Earth as being a self-regulating organism. Like a living organism, like the human body maintains itself at 98.6 all the time and maintains a lot of systems. Moving away from an equilibrium would move us back again, partly due, in the Gaia Hypothesis, partly due to the biosphere. Okay? Moving far enough away and you start to climb out of the basin, and that looks dangerous. Another thing I'm going to talk about is the attractor at affinity. I have some of this on a future slide. Venus is the model for this, a runaway climate. And then finally about some determinism dynamics and a climate change version of how the California wildfires happened past summer. So the Gaia Hypothesis and attractors at infinity. The Gaia Hypothesis, the Earth is self-regulating like a living being. Among the other things that the Gaia Hypothesis people hypothesized was that, if the climate warms due to increased carbon dioxide, then that makes the warmer climate allows a lot of lush plants and increased forestation. That converts a lot of the carbon dioxide into oxygen. The carbon dioxide level goes down and the Earth begins to cool again. So warming would produce a future cooling if it was in balance. Okay. On the other hand, if the Earth cooled somewhat, then the lack of plant life, deforestation caused by the increased encroachment of ice and cold temperatures, should lead to the imbalance moving more towards the side of carbon dioxide, and it should warm back up. And the idea of the Gaia Hypothesis was that the Earth had been in some kind of balance like this that included included life forms on the planet, plants and animals, and that the problem would be that if things were doing the wrong thing, that we were ruining that balance. And that's largely right from the point of view of equilibrium. If the planet is not at equilibrium and we're moving the needle, then it's not that we're creating too much carbon dioxide, it's that we're creating more than can be removed. And that's why it's building up. Okay? And 50 years ago, for those of us that have been around that long, 50 years ago, Venus was the place we were expecting to find life. There were lots of sci-fi shows on TV about Venusians and stuff like that, because it was a similar sized planet. It had clouds. It was close to the same distance. Very similar sun. Right? And we assumed that we were going to find life there. It was going to be pretty much like Earth, maybe a little warmer. When they actually started doing studies and measurements and then finally sending satellites, this is false color because you can't actually send a probe down to look at the surface of Venus. The atmosphere is a heavy piece of insulation. It's like having a much thicker blanket than the Earth. and under the thick blanket you warm up more. The atmosphere has a lot of sulfur and carbon compounds in it, and the surface of the planet has molten rivers of molten metal. Okay, and that struck a lot of fear into a lot of people's minds, because the Earth was beginning to heat, and we have a lot of frozen methane on the Earth that would add a lot of greenhouse gases if it got warm enough for that to begin to boil. There's a lot of trapped sulfur, both in surface minerals and in plant life and animal life on the surface. If that all started to catch fire, we would end up with somewhat of a similar atmosphere, and instead of being something you could correct, it would be run away, and we would end up like Venus. So that was known as the attractor at infinity, because once you pass the basin boundary, you're headed for the temperature just increasing without bound. Obviously, it would increase only up to how much energy was coming in from the sun, but it would be a long way towards hot. So the other part about moving out of the basin in which our equilibrium is those tipping points. Tipping points mean that you're going to leave the basin for another basin, and basin boundaries, it's all very deterministic. If you were to follow exact opposite path leaving the basin, do everything exactly like you did leaving the basin, you could retrace your steps. But basin boundaries don't have to be very simple. People are aware of this, the Mandelbrot Set? Yes? No? Okay, so this is a source of, a ton of Mandelbrot Set art online. This beautiful image here is a zoom in on a portion of the boundary of the Mandelbrot Set. So if you think of how complicated this is, if you've seen any of the movies where you zoom in and it stays complicated as you keep zooming in, retracing your steps after you've moved from here to here, unless you hit the exact place, exact path going back, you'd end up someplace else. Well, someplace else might be okay. I mean, if you remove the carbon dioxide from the atmosphere, it might be okay. It might cool the planet back down again, but it might be a different climate than what you had before. And so, how many tipping points do we actually have? This is from an article that if you feel like reading up on this kind of stuff, you should really get a hold of. It's online. It's from the Proceedings of the National Academy of Sciences, PNAS. It was in 2008, I believe, or 2008, and it's by Lenton. It's called Tipping Elements in the Earth's Climate System, and it shows a few of the tipping elements. We could get a permanent change in the frequency of the El Niños, or the size of them. Some of the other ones, the chaotic multi-stability that is the Indian monsoon could change. The Indian monsoons would change. The permafrost and tundra loss, the one that you do hear about in the news, is the Antarctic ice sheets and the Arctic sea loss and the Greenland ice sheet. But some of these other ones are just as important. A West African monsoon shift could cause the Sahara Desert to green. That would change the climate. That might change it for the good, it might change it for the bad. The problem is that it's very difficult to know what each of these changes will do, except for one thing. I'll mention it later, but I'm going to mention it once now. If you take a piece of land and that is a piece of the desert and start watering it, it's going to be a long time before you have enough soil there to start planting things. If you take a piece of land on which you're in the Central Valley, on which you're planting a lot of stuff, and stop watering it, the plants die right away. So on average, when you change the climate in an area, and you change around where the hot and wet and dry and places are, on average you lose food. That's a point to remember. So all of these things affect the weather. The weather and the climate are intimately related. And that's kind of the thing that kind of bothers me about the coverage on the news. It affects the whole weather, not just the storms. It affects the loss of glaciation affects a lot more than just causing the sea level to rise. Okay? So the problem I guess one of the problems I have with the news is that I don't think they're telling the story quite bad enough, if you catch my drift. Okay, what gets affected? When you change around when the heat and cold affect where the lows and highs are on the planet. And when added to the Earth spinning, that forms the cells that form our weather. Okay, when you change where the hot and cold places are, all the different currents change. What gets affected? Well, monsoons, cyclones, snows, rivers, ocean currents, pretty much everything. There's a new set of seasonal currents, and that becomes the new normal. Is it habitable? Well, we don't kind of know. But like I said, the odds are not good. So now going to go from that general case to the specific. Glaciers, ice caps, and the weather. The ice caps we do hear about in the news. Antarctic, the Arctic ice cap, the Antarctic ice sheets, and the Greenland ice caps. You hear about those. Rivers and sea level you hear about. A large number of rivers start in the Tibetan Plateau, and that's a glacier, an ice cap, a former ice cap that you don't hear quite as much about. How many rivers start in the Tibetan Plateau? Well, they start with the Indus River, and you move across all the major rivers of Asia, South Asia and East Asia, up till you get to the Yellow River, including the Yangtze, the Mekong, the Ganges, the Brahmaputra, all of these rivers, okay? And it's estimated that the food supplies of close to 3 billion people are invested in those rivers, and invested, therefore, in the fact that their headwaters is in the ice up in the Tibetan Plateau. So the Tibetan Plateau is like a third pole. There's circulation around it. The circulation used to be different. Right after the Ice Age, the Tibetan Plateau was year-round ice. It was like a third ice cap. Okay? Then, around 10,000 years ago, it started to become seasonal. By the time 4,000 years ago came around, that seasonality started causing large changes in the monsoons. What is that responsible for? My arrow has moved on this thing. It's actually supposed to be here. The Sahara Desert was 5,000 years ago was a savanna. The Kizilkum Desert was a marsh, and the Taklamakan Desert was moist. The less soil over China came as the Taklamakan dried out and blew the soil over into China. The same process is happening right now with the Lake Chad Basin, which is drying out, and the fine soil is blowing over to the Amazon and fertilizing the trees there. The Asian brown cloud is another effect, possibly, of that circulation involving the Tibetan pole, depending on when it started as a phenomenon. There's some discrepancy. If it started in the 1930s, then it's kind of like a red spot, like Jupiter's red spot, something that's always there and either fills up or empties out of pollution. Okay? So the monsoon system, the cold in Tibet shapes the summer and winter monsoons. The monsoons plus the Arctic isolation shape the Diablo and Santa Ana winds, which I'm sure you guys are all familiar with. So here's the winds on the Tibetan Plateau. There are westerlies, which are due to the rotation of the Earth, that move this way across the top of the plateau. These winds down here move because the ocean is cooler than the land and it brings moisture in, but the plateau itself is cold for quite a bit of the year, and it causes a particular rotation similar to the polar vortex. And it shifts from the summer monsoons, which are basically currents moving up this way, to a winter monsoon, which is cold wind moving down from the top. When When the glaciers disappear, they'll end the water supply, regular water supplies, but they will also change that pattern. It's estimated that at first the monsoons will get heavier and more erratic, and more of the water will actually be dumped not in South Asia, but start to be dumped in the Tibetan Plateau itself. So this is all deterministic stuff. The bottom parts of my slides are getting cut off here, but I can do this anyway. This is all deterministic stuff, and that's part of why you don't hear about it, because it took me all of that explanation about basins and everything to be able to really talk about it. So here's a progression. Over there in the corner, the summer monsoon switches to the winter monsoon late. That's caused by the weather and variables related mostly to the Tibetan Plateau itself. That causes the snow in Siberia, the snow that builds up in the snow cap building up in eastern Siberia in wintertime to be late and the snow to be heavy. Okay? That causes the Arctic oscillation up at the top to change. It contracts, pulls the Arctic weather closer to the top. The waves that come through that they show on the TV set that are called the jet stream when we see them are higher up in latitude. That causes, and the rest of the slide was supposed to say, that causes a strong high to build up over Western Canada. The strong high over Western Canada increases both the strength of the Diablo and Santa Ana winds, and it causes it not to rain first. So the net effect is it hasn't rained yet. You have 70 to 80 mile an hour hot winds, and it's a recipe for fire. Okay? And that causes the fires in Northern California. The last 2 years, the winds fueling those fires have been between 60 and 80 miles an hour, like a hurricane. Okay? So, and that originates over in Asia. So, what will the melting of the Tibetan Plateau cause? Well, it'll cause problems for all those countries that are losing their water, but it'll also cause problems for us. Likewise, problems that start here with the hurricane system that comes off of Africa is based on the borderline between where the desert, hot desert and sandy, less winds coming off of the Chad Basin ends and where the tropical climate begins. That interface there, as it varies back and forth, as the seasons change, causes the initial spark that causes the hurricanes to come across the Atlantic. If desertification moves that line south, they'll be coming across the Atlantic further south. The water will be warmer, the hurricanes will be stronger, and something in Africa related to climate change will have caused stronger hurricanes in the Americas. So it's not, there's several take-home messages from that. There's a take-home message that it's going to cause huge changes in the weather, and there's the take-home message that it doesn't matter where in the world you are, something that's changing the climate in one part of the world is going to affect you in some other part of the world. And that message, I don't think that resonates too well in the news as well. Okay, so then the last topic I wanted to cover, which is never talked about as far as I know in the news, is talking about population. Okay, I'm going to christen the theories about your diet having a positive or negative impact on the climate as vegan theory. It is a theory that is most widely promulgated by people, members of the vegan community who are vegans because they're hoping to help the climate. Okay, papers done by them, that community and the scientists that are related to those projects estimate that what the world eats contributes 25 to 37% of the anthropogenic climate change. Okay, that's a quarter to a third. Okay? there's a paper that was just reviewed in the New York Times about a month ago called The Great Die-Off and the Little Ice Age. The Great Die-Off was the die-off of people in the Americas when the Spanish got here in the late 14 and early 1500s. Okay, you had the assumption by the authors of the paper, Alexander Koch and his co-authors, was that the die-off is due to what they call virgin soil epidemics, which is when somebody comes to a land where there's no resistance to a disease, and the disease reaches epidemic proportions quite quickly. It was estimated that his paper estimates that 60 million people died over the next 100 years. Okay? And that, he estimates, was a contributor to the Little Ice Age because the fields then became fallow, went back to being forested, and the decline in human agricultural land was enough to contribute several degrees to the Little Ice Age, which occurred near the same time. It's worth noting that 60 million people, we have added 100 times that number of people since the end of the Little Ice Age to the planet. It's also, just to put some things in perspective, there are some rebuttals to what he wrote. Acuna Soto et al. Wrote an earlier paper showing that the very first of the diseases that caused the Great Die-Off was actually indigenous. It was a hemorrhagic fever that the Aztecs called Cocolitztli. Okay? Which kind of means that big epidemics could happen in the Americas anyway. Not to say that this wasn't a much bigger epidemic than would have happened otherwise. Big epidemics 100 years previous to that had happened in Europe, called the Black Death. So if epidemics are causing that much climate change, then we have a problem, because it means that the sheer number of people on the Earth is causing large percentages of the climate problems. The Berkeley Climate Group said that they thought that the impact of the big die-off was considerably smaller. I should mention that. So does diet as a solution tell us something about the population? If it does, actually, and one of the things it could tell us if we were listening was that if our traditional diets cause that much change, then we need to worry about whether or not there's too many people, whether or not the problem is just the size of the human population on the Earth, to some extent. Obviously, there's a huge component of it that is industrial. If that's the case, with or without that, worrying about that, there are going to be large displacements of populations due to climate change in the future. There's already beginnings of a displacement out of sub-Saharan Africa, the Sahel. As the Sahel becomes drier and people try to migrate north as their crops are not doing well anymore. That's one of the causes of the migration north towards Europe. There's also, at the current time, 70 million people in the world are forcibly displaced. Okay, 70 million. 40% of Bangladesh will need to move just due to sea level rise. So that's already started, actually. People are beginning to move inland. In general, when people from rural areas migrate looking for a way to get food, they have a tendency to move into urban areas with relatives or without relatives in search of moving from agriculture to some kind of jobs. Dhaka can't really sustain that many jobs, and many Bangladeshis are trying to move outwards. You see them trying to move into India, into Myanmar, into other countries around the area. And we have migrations coming up from Central America. Some of those are quite political. Others appear to be, at least coming from Guatemala, disputes over the farmland use and people being moved off of their farms. Okay? We go back to the tipping point that I mentioned before, the food production tipping point. Changes in local climate tend to destroy food. Okay? That's something that's pretty much a firm fact. It's going to be a rare case when a change in the local climate is going to create new food resources. So this is going to continue more and more, not just from sea level, but also from people their farmland being unproductive, the way it is in Western Africa. Okay? When that happens, people are going to move. They're not going to sit there and starve to death for the benefit of humanity. We already are having political problems with the 70 million displaced that we have right now. We're having political problems in the United States, which are, of course, amplified. We have amplified problems in Europe. There are also problems in Asia. There are problems pretty much all over the world with people migrating in large numbers. It's not clear that the size of the migrations caused as the climate change really begins to come out of the background noise are going to be something that is going to be welcomed with open arms. People are probably going to begin fighting about food. So, summing up, in reality, scientists don't actually vote. They collect data, analyze, and prove theories. I appreciate and I like the fact that people are using the fact that 97% of scientists agree that climate change is real and is caused by human beings. This is a good political fact to use, and I appreciate every single one of the people that beats politicians over the head with it. But in point of fact, you could remind yourself that in 1880 or so, 100% of scientists didn't believe in quantum theory either. So that's not really the way science is done. Actually, the people that started to say that climate change was real started from a very small number of people, and the most modern movement really began at NASA Goddard in the 70s. Events happen for deterministic reasons. But the system that they happen in this particular case, the weather, is that big spirally thing I showed you earlier, the Lorenz Attractor. So even though they happen for deterministic reasons, that doesn't mean you can necessarily turn the clock back. Not everything is reversible, even if it is in theory. Okay? Weather matters, even for climate, and weather and climate do interact. Okay? How much the weather deposits to add to a particular piece of glacier or ice or something like that affects the size of that glacier, even though the ice that you're really worried about is the old ice that is disappearing and can't be replaced by the weather. Weather changes can affect how much of the Earth reflects light, how much of the Earth doesn't reflect light well, where the clouds are, and so forth. So it does have an effect on climate, and climate has an effect on weather. Watch everything that's going to lose its stability. Anything that's going to change and go from being something you could count on, usually, to something that you can't count on. It depends, sort of. Where I grew up in New England, you could count on the month of January being super cold and the month of February being a lot of snow. People have been seen riding their bicycles in shirt sleeves in January recently. I mean, there is something called a January thaw, but that's a little on the ridiculous side. February, the snow doesn't always come. A lot of the ski resorts up there have problems with how the weather is uneven from season to season. Likewise, some of the people that have been flooded in the Midwest recently talk about how they've had floods before, but never like this. Okay, so watch everything in which something is no longer stable, whether it sets a record or not. Failing to talk about population is probably a recipe for failure. The population of the world is supposed to go to 9 billion by the end of the century. People talk in terms of making plans to feed 10 billion people. It isn't really clear that some of the things that we're trying to do about climate change are going to continue to work if the population continues to grow that fast. And second plug for this special issue here, it's December 8th, 2008, I believe, not 2009, but The feature is in Proceedings of the National Academy of Sciences. If you look up tipping points, PNAS, on the internet, you can get to it. It's a whole special issue. It deals with each particular tipping point separately. It's well worth the read, and we're very grateful that the National Academy of Sciences commissioned that work. And that's pretty much my talk. Are there questions? You have to bring the microphone in.
Okay, the drill's always the same. Yeah, remember to hold the microphone close to your mouth. Also, please, let's not have people talking for 10 minutes before they ask a question.
Yeah, I like your tipping theory, but I have another tipping theory that I have heard of. You have a trough of water that's several inches, feet long, and you find the balance point and you put a hinge there, and so you make a teeter-totter. Okay, now you put a submarine in the center of it, and because the submarine is displacing its equal amount of water, it can move any place in that trough without, because it displaces the water. As it moves to one end, it forces its equal weight of water to the other end. So it can move back and forth. So you can use that as a model. Now you bring this submarine back to the center and sink it. Now it isn't displacing this equal amount of water, so when it moves to the left or right, it changes the balance point, and it'll tip. And if it tips enough, the water will fall out of the trough.
So what's your question?
Well, I just want to make, that is the, I'm making a comment of another tipping point model.
Okay, so I don't believe that the climate tipping points are of that sort, because basically, if you remember my state space, tipping point means that you're moving from one place in state space to another, and that something is changing, and that it will make a permanent change when you cross it. Okay?
If it's floating, you know, whatever.
Right, I understand the experiment. It's just that the tipping points are in the phase space, they're not in.
Yeah, okay. I've heard it used as a model. Okay.
You done now?
Yeah, I'm done.
I have a question about Venus.
Venus, yeah.
Yes. Now, is the temperature of Venus due to internal heating, or how much is contributed by the sun being absorbed and not radiated?
It's widely believed that the temperature of Venus is largely due to the fact that the energy from the sun comes in and is not radiated. It is volcanic. There is volcanism on Venus, but the fact that its climate differs so much from the climate of the Earth is believed to be due to the atmospheric conditions. Yeah.
I was a journalist for most of my career, and a lot of newspapers and magazines. I blush to say I was a sports writer, but it was a good job. But when you said the media up front doesn't want to report on these things.
I didn't say they don't want to report it, I said they don't report it.
Okay, so you separate don't and want, but
Right.
do you have a reason they don't want to do it? Is it because it's too scary, or what is?
Okay, so I think it's probably poor politics, regardless of where your politics is one factor. A bigger factor is that the media likes to keep the numeracy level of their articles very low. They don't.
So what factor?
The numeracy, the amount of numbers and things that are, and the manipulations, especially manipulations like algebra or worse, they don't usually use a lot of. And that makes explaining some of the things more difficult. And they also tend to like short, concise explanations that they can fit into an article that is going to principally be that plus other things. So they don't tend to like an explanation that's going to maybe take a whole page to do. If you notice, my basin boundaries explanation took me 3 slides with figures and stuff. So some of it is that it's not the right, it isn't a media conducive to doing that, and some of it is also, frankly, that they're much more fluent in other kinds of math. In statistics, like I said, they use that for sports, and they also use it for other things, but they're very familiar with reporting statistics, and they're very familiar with reporting polls.
I'm also very aware of the most popular things people like to talk about is what they write about.
Right.
And being my sports years, I got very disappointed in the Mercury News as among all the other papers for continually writing baseball, basketball, and football. So you'd never do water polo or the other junk. It's what's popular for.
That's true.
I don't know whether this isn't popular.
It's also partly the scientists too, because it's very much easier to defend a statistic like February was the wettest month on record than it is to say, well, this is going to cause a lot of changes. What are the changes going to be? There's no way of knowing for sure, but they're likely to be bad. And that makes a much harder thing to defend if you're going to be immediately politically attacked.
I have 2 questions. The first one is, do you have any statistics or numbers about how much of this effect could be ameliorated by zero food waste?
I don't have one on food waste. I do know that there's a lot of food waste in developed countries. That kind of actually hits up one of my favorite spots, which is that we actually are consuming at a much higher level than we consumed even 40 years in the past, in terms of things like air conditioning, in terms of food waste, in terms of replacing things instead of repairing them. So I'm not really aware of exactly how much that would benefit the ecosystem, but my guess is that it would benefit it quite a lot. As for not putting as much carbon dioxide into the atmosphere, it depends on where you let the food rot. I mean, it depends on whether that's actually going into the atmosphere somehow, or whether it's being composted, or what's happening to the food waste afterwards.
And my second question is, what is the likelihood that this is going to cause either many instances of species failure that then lead to like ecosystem collapses on a catastrophic level? You didn't talk about that at all, but that's one of the things it seems like could happen.
Yes, it could. And including, by the way, our species. The human species has never lived in more variation of climate than a few degrees, than a degree or so, a little more than a degree Celsius from what was normal in the 1800s. We're already 1 degree away, and we're moving most likely beyond 2 degrees away before even if we were to mitigate it and move back again. And I think it's not, I mean, humans have a propensity for thinking, well, what's going to die off is everything else, but it could very easily be that we're amongst the species that don't make it when the climate changes that much, or make it in a considerably reduced form. As for some of the other species, you are beginning to see species either die off or move north. There's quite a few plant species that have either moved north or are beginning to die out. It all kind of depends on barriers, whether they can successfully move north, or if they will die out. And if certain species, the ones that pollinate our fruits and vegetables, for instance, die out, then the results of that could be catastrophic. Yeah.
No, give it to her first. No, give it to her.
Okay, I just wanted to add to that. A recent experiment is, or recent it's a survey of insects, and it's been found that there's been a 25% decrease in the insect biomass because of local variations in climate. So, and insects are the most popular species collectively, and they account for a very large amount of the biomass on the planet. And so, and this is considered pretty catastrophic because the declines happened in 20 years.
A very good talk, but I have a question differently than scientists are kind of isolated from the socio-political environment. And she mentioned about the insect population being declining. For ordinary people, how the scientists getting out of their cocoon and spread what will be the real impact in a common language, in an ordinary people language, rather than scientific language. If the decline of insects and the butterflies are going away, ordinary people don't care. How do and in a socio-political environment, they are more interested to generate capitals. And how do you generate capitals? So from that perspective, how the community like us and also the scientific community can use the same tools they use, like PR and marketing, and popularize, not popularize in the sense of marketing popularity, but make public aware the danger, not with the scientific terminology, but using their vocabulary.
So one of the things that is being done in that direction is to team scientists with people that are good at getting messages out, either people in the advertising community, people in the press community, to put together, for instance, some of the NOAA and NASA have begun putting together climate documentaries that are accessible, that are up there on YouTube with all the other stuff that's up there on YouTube. As well as in some places, people like glaciologists and climate scientists go and give talks. That's probably not enough. And there is a lot of negative feedback in the current political environment, which has a tendency to scare scientists, to be quite frank. What happened with the data that was leaked, the emails that were leaked from East Anglia in Britain, it was a huge shock to a lot of scientists to watch the way some of what they were doing for their work was being construed, and to watch the way it got distorted. So I'm not really sure that's not really an answer to your question, but the answer is generally when you want to have something that's a difficult scientific thing presented to a public that may not be that interested in it, then you need to employ the people that present things to the public. So you need to employ people that know how to put together a good documentary, and then you need to employ people that know how to get the word out about the documentary. You need to find people that are willing to, say, plug it on their news shows and things like that, and get a lot of people watching it, up to and including getting Hollywood into the act, because Hollywood does actually have a lot more social influence than some people give it credit for. If you put together a good story, a good movie that gets people involved, and run before the credits, run some information about where, like they sometimes have when the story is true, they have a few lines at the end of the movie, then you can sometimes hit more people doing that than you can just doing straight science talks.
Okay, any more questions? Surely somebody has some.
I read articles about astronomy, and they're looking for Earth-type planets, and they talk about the Goldilocks Zone, where it's warm enough that water doesn't freeze and it doesn't all vaporize, and that's a region. And I wonder, it's not my question, but I kind of wonder how much the atmosphere influences that.
Well, how much
the atmosphere influences whether water can remain liquid or whether it will freeze.
Oh, it
and
does.
yeah, the question though is, I haven't really heard a worst case scenario other than Venus.
A worst case scenario other
Yes,
than Venus?
yes. We don't know where we're going when we cross the tipping point. Has there been serious speculation that we are, if we don't move fast, we're on our way to Venus?
On our way into Venus. So the tipping point that was envisioned it was basically NASA Goddard people in the 1980s that were talking about that particular set of tipping points, and they construed it as one big tipping point. You get to that tipping point by getting to the level where the frozen methane on the surface of the Earth begins to sublime into the air, by getting to the level where you start to have massive fires that rage for months and stuff, because that starts to release sulfur and carbon dioxide into the air. And those are the kinds of events that begin to fill the air up with the kind of stuff that's in the atmosphere of Venus.
But they haven't said exactly how bad it will get, whether we're going to be melting.
Exactly how bad it will get?
Yeah, we have molten rocks.
The original theory was that if the atmosphere got contaminated with enough carbon dioxide and sulfur dioxide, that it would do the same thing, because we're roughly the same distance from the sun.
Okay, the other comment I want to make is you talked about population being a problem, and I
Yes.
agree with it. As far as I know, the only country that's tried to deal with a population problem is China, and they haven't gotten a lot of good press about it.
There have been movements in the past, even in the United States. I think if people remember the late 60s, early 70s, there was something called the Zero Population Growth Movement, based on Paul Ehrlich's The Population Bomb. I have a feeling that some of those kinds of problems, some of the population problems actually just tackled by education of women. It tends to bring population growth rates down. And some of the problems involved with that may need something more draconian, but basically if you don't start talking about it, then it sits out there as a problem that we're just going to allow to continue to fester. And so I don't pretend to know how you deal with the population problem, just that it's out there. We shouldn't be excluding it from our coverage of climate change.
There are vast areas of the planet in Siberia and Canada which are virtually uninhabited. What are the implications for global warming, making these areas more productive and inhabitable?
The short answer is I don't know. Okay. The longer answer is because we don't know how those areas would warm up. Okay. Tibet, like I said, went from being glacial and covered with ice to being post-glacial and having warmer weather in the summertime. It turned out that the Tibetan Plateau ended up being mostly arid. Okay, but a change, like I was saying, in the monsoon winds would cause Tibet to be less arid. So it's the whole system interacts with itself. Right now, the monsoons are very dependent on the Siberian tundra and the snow accumulation there and its effect on the Arctic Oscillation. Well, the Arctic Oscillation is going to become more chaotic in the future because they're estimating that the Arctic polar ice cap is going to go away in summer times. So that's going to change the dynamics there. The dynamics of the monsoon will change when the Tibetan Plateau starts to melt. So what looks like is land that could be much more useful if it was just a bit warmer there right now. It could go either way. It could be very arid land. It could be habitable land.